Kia ora, I'm going to have a little look at residuals. So I've got NZ Grapher open and I've got the data set that we were looking at, the household savings data set. So remember, to pick your data, best thing to do is go into pairs plot. Today I'm going to have a look at, I'm going to go age versus age of partner. So I've actually done it the other way around, the age of the partner, and I'm using age of partner to estimate somebody's age. Remember, the order matters, but we're talking about residuals. Anyway, what I want to do first is I'm just going to show you how I can clean this. See, I've got all these zeros. 0 for age of partner means that their partner is aged 0, therefore their partner does not exist. So I'm going to get rid of that first. So I'm going to filter the data, and I'm going to filter it by the age of partner, and I'm just going to do it between the ages of 1 and 60. The reason I'm doing that is so it's going to get rid of all those zeros, and you would have to talk about this if you were doing it in your internal, but I'm just going to do it now so we can do some nice residual plot. As you can see, I've got my regression line in there, and what I've sort of noticed in my regression line is that between the partner ages of 20 and 25, you can see that our regression line underestimates the age based on the age of the partner here, because there's no data above the line, but there's lots of data below the line. Also at the top end, I can see between the partner ages of 50 and 55, estimating age from there, you're going to underestimate. So actually, I can see that a curved model might be a better fit. You could just tick down here and put a curved model on. And I can see on the blue line here, even though I've complicated the model a little bit more, it's doing a better job of estimating somebody's age based on the age of the partner. But we can't just skip straight to that. If we're going excellence, we want to learn how to find out about that via residuals. So what we're going to do is, using the same variables, I'm just going to change graph type over to residuals plot. So it's just 2 below scatter graph. And what we can see here is, I'm just going to put it back to where it would start for you guys. So it will be set on linear regression. So that means it's looking at your straight line. And up here, this is actually a plot that shows, well, I should probably move where my face is. Give me 1 second. My face is going over here. As you can see on this graph, what it's doing is right now it's looking at fitted values. So if the fitted values means what's on your y-axis. So when we're looking at people's ages, we can see that the model is going to be that dotted line across the middle. So essentially what residuals is doing is where's my hands? It's sort of it's a plot based on where the model is, and it's saying where is the data above the model and where is the data below the model. So we can see here that it was the same situation, that we were having a lot of data below the model initially, and then we're also having a lot of data below the model at the end. I like to change the x-axis so I can talk about my predictions. So now our explanatory variable is across the bottom. So that means it's consistent with what I was looking at before, where the explanatory variable is on the x-axis. That means if I'm looking at the partner age between 20 and 25, the model is underestimating here because more data is below the model. Now, there's actually a button that averages out everything. Rather than looking at points individually in statistics, we want to look at it holistically. So this line here called a weighted average line, and if you talk about this deeply, this is where you're going to get your excellences. You can see that the weighted average line is below the model. What that means is this data is pulling that weighted average line down. This blue line here is averaging overall the data in that area, right? And so we want to check how close that is to the model. Remember, residuals plot is just a way of putting the model across the center and seeing where the data is in regard to that model. So it looks like at the age of partners for 20 years old, it looks like that most data is 1 below. So if you were making a prediction for a 20-year-old partner, a 20-year-old's aged partner, and you're trying to estimate how old the age of the person would be, it's going to be, your predictions are generally going to be -1 from there, right? And as you can see in the middle, it does pretty good for estimating a 32-year-old person. But then anything from 32 up to 48, you're going to, it's going to be over the model. So the data is going to be like half a year above what the model is predicting. So then at the end, then it goes down. So what you can do in residuals is you'd paste this on, have a discussion about what the weighted average curve is telling you and what that means for your predictions. Then you can start testing different types of regression or different models. So for our one, we looked at quadratic, and quadratic looked quite good, and residuals is going to confirm that. When I click it, you'll notice that it means that it fixes it at the bottom end and it fixes it at the top end as well. This weighted average curve is way closer to the model, which means that your model's doing a way better job of finding averages at different partner ages. So from 20 to 25, it's doing good estimates. From 25 to 30, all the way along, it's making really good estimates. So quadratic is probably a far better suited model. I just want to talk about the x-axis again. It's easier to change the x-axis because it means that your explanatory will be along the bottom, but you can totally do fitted values if you want. I'm just going to explain what fitted values will do. So let's go back to the scatter graph of this. So fitted values means that instead of looking at the partner age, we're looking at the age and we're sort of bouncing it off. Boing, dong. So it's sort of a little bit confusing to get your head around, so I would personally just change that x-axis. So let's have a look at the quadratic model and see that it does a way better job. Essentially, that's what we found in our residuals. It's a way to look at what a better model might be. It might be able to help us to make a call about whether our prediction is going to be accurate. And yeah, that's why we use residuals pretty much. I hope that helps.